Welcome back, Math 2. Today we are starting our last unit of semester, number 401, Unit 4. This is still going to be about quadratics. Now we're going into interpreting them and what is the point of doing all these things with quadratics, okay? So, we're just going to do a quick video to recap some of the really important pieces we need to find. So the first one is finding x-intercepts, okay? So just a reminder of what that looks like. Whether your graph is going up and down or whether it's going up or going down, those x-intercepts are where the graph crosses, remember it's called a parabola, where the parabola crosses the x-axis. Okay, and we find these x-intercepts by using one of those methods to solve the quadratic. So that could be square roots. That could be factoring, could be completing the square, the AC method, quadratic formula. I would say with these more real-life application problems that we're going to be working on, these two are going to be the main forms that you use to solve. So I'll just give you a quick reminder on what the quadratic formula is. You've had a lot of work with it, so I'm not going to do an example. But out of ax squared plus bx plus c, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. And with factoring, let's say we had x squared plus 6x plus 5 equals 0. Factoring is where I'm going to set up two parentheses. And in those parentheses, I'm going to put an x in each. And then for the numbers, I want two numbers that multiply to make 5, but also add to make 6. Well, the only factors of 5 are 5 and 1, and it just so happens that if I add 5 and 1, I get 6. Those are going to be my two factors. So unless your equation is factorable and doesn't have a number in front of x squared besides 1, you're probably going to use the quadratic formula a lot, just because you know it's guaranteed to work. Once you get the hang of it, it goes faster and faster. Okay. From this point, I'm going to split up my two parentheses. I'll have x plus 5 equals 0, x plus 1 equals 0. I'm going to subtract 5 and 1. So my x-intercepts are negative 5 and negative 1. So that just means if I had to graph those, that my parabola is crossing here and here. That's all I know about it so far. Okay. Finding a vertex. Okay, a majority of your problems are going to be in standard form. Okay. Which is that form I wrote up here earlier, ax squared plus bx plus c. So to find the vertex, remember that vertex is also called the maximum or the minimum. It's that spot where the graph turns around. Okay. I find the vertex. I start by finding the x-coordinate, where I use negative b over 2a. Then to find y, I plug whatever I get for x back into my equation. To get y. Wow. Okay. So I will do an example of this for you. Let's say I had... I'll do two examples actually. We'll do two quick ones. X squared, and we'll pull the one from before, plus 6x plus 5. Okay. I know b is my 6, so I need negative b. So negative 6 over 2 times a, remember, which is a 1. So if there's no number in front, there's really a 1, which is really negative 6 over 2. And if I divide that, I get negative 3. So this is my x-coordinate. So my vertex is negative 3 comma something. I'm going to take this negative 3 and plug it back in for x. So instead of x squared, I'll have negative 3 squared. Instead of plus 6x, it'll be 6 times negative 3. Now I'm going to solve this. So negative 3 squared, it means negative 3 times another negative 3. That's a positive 9. 6 times negative 3 is negative 18. And I still have plus 5. So 9 minus 18 is negative 9. Plus 5 is negative 4. That is my vertex. Okay. Let's try it where it may not come out so nicely. So let's say I had 3x squared plus 4x minus 6 equals 0. You can still do this even with a fraction. So I'm going to use b again, which is 4. So I have negative 4 over 2 times a, which is now 3. So this is really negative 4 over 6. If I reduce that, it's negative 2/3. Now you can either keep it as a fraction or use a decimal. With a third, since it's repeating decimal, I would prefer you to keep it as a fraction. Okay. So my first coordinate, or part of my coordinate, is negative 2/3. And I'm going to replace all my x's with this. Okay. So first off, 2/3 squared. Let's see, 2/3. What am I doing? And I'm just going to use a positive 2/3 in my calculator because I know that if I take a negative 2/3 times a negative 2/3, it should end up being positive anyway. So that's 4/9. I'm going to take that times my 3 while I still have it in the calculator, and that's 1 1/3, or you can list that as 4/3. This will be a minus, so 4 times negative 2/3 is negative 2 2/3. And I personally just like improper fractions. If you want to change that, you can use that fraction button again. So that's 8/3 minus 6. Okay, so 4/3 minus 8/3 minus 6 is negative 7 1/3. You can use that. Or if you like improper fractions like me, that's negative 22/3. Okay. So that's how we find the vertex. That vertex point is always helpful. It's super crucial to know how to find that. It's going to come in very handy. Okay. On the back, the y-intercept. Again, since most of our equations are going to be in this standard form, the y-intercept is crazy easy to find. So the y-intercept happens when x equals 0. So if I think about it, no matter what the number is, if I plug in 0, that's going to eliminate my a term and my b term and just leave me with c. Okay. So the y-intercept is always going to be our 0, comma, whatever c is. Okay. All right, now let's talk about graphing. This is going to be the big one. Okay. So there are some steps to graphing. You want to just be able to find 2 to 3 points. Okay. And one of them must be the vertex. Okay. Because if you don't know where that vertex is, you're not getting a good picture of your parabola. Okay. So we're going to bring in our example. You know what? Let's do a quick example up here for the y-intercept. If I have my x squared plus 6x plus 5, if I plug in 0, my y-intercept would be 0, comma 5. The reason I'm going to use that is going to be our example for graphing. Okay. So let's say you have the vertex plus 1 point. Okay. And typically that 1 point can be the y-intercept. Okay. So again, I'm going to bring out that x squared plus 6x plus 5. We already found the vertex for this on the other side. It was -3, -4, so we did that work already. Okay. All right, so I'm going to go ahead and graph that. 1, 2, 3, 1, 2, 3, 4. So there's my vertex. Okay. We also found the y-intercept up here. It'd be very easy to do again. I just have to plug in 0 for x, and I'd get the 5 left over. Okay. Here's why this is so simple to graph with just the 2 points, even though it's a curve and we really need to see 3 points. So I know my y-intercept is up here. My vertex is also the point where the graph is perfectly symmetrical. Okay, this is called the axis of symmetry. And since my graph is perfectly symmetrical, it makes a really nice curve on either side. I know that this point should be reflected across this line. So right now it's 3 spaces away from this line, or 1, 2, yep, 3 spaces away. So on this side it should be 1, 2, 3 spaces away. There should be an exact point across from it. And now, because I have that, I can draw in my curve. So this was my y-intercept, this was my vertex. I was able to draw my curve. What if you had the x-intercepts? Okay, which by the way we found on the front as well. They were -5 and -1. If you want full coordinates, that would be -5, 0 and -1, 0. So we have 1 at -5, 1 at -1. Okay. All right. And we also already found the vertex, -3, -4. So that would be right here. Okay. Again, that vertex is right in the middle. Even if we were to draw this in, if you notice, each x-intercept is 2 spaces away from that middle. Okay. So I can again draw in my line, or my curve. So my vertex down here, my x-intercepts here and here.